So you want to make this, and this, and even something like this. With WebGPU you can. In this video you will learn the basics of WebGPU and how to use WebGPU easily with my library called Points. Now, as a disclaimer, I don't know everything about WebGPU. I could be very wrong in a few things I say. So be aware of that. This is mostly focused on 2D rendering, and I'm still working on this library. We're going to use the depth branch, and you can check over here all the examples from the library. What is WebGPU? So WebGPU is an API that exposes the capabilities of GPU hardware for the web. You can check that at w3.org on this URL. WebGPU is also the successor of WebGL. It doesn't mean that WebGL is discontinued. All the applications made in WebGL still work. It just means that WebGPU has some performance improvements, and that it will be the new standard for the web from now on. So WebGPU is an API for 2D and 3D graphics, and I will say that it also works for math calculations. It runs tiny programs called shaders, and every 3D game you have ever played has shaders. So what are these shaders? There are three types of shader. You have your vertex shader, your fragment shader, and your compute shader. Your vertex shader is the program that handles basically a 3D model, which is described by the points and triangles. So a vertex shader handles triangles, like a 3D model, a cube, and any type of 3D model that you ever seen in a game. It's described by triangles, and these triangles have a vertices, and you can do certain type of manipulation with these points, like animate them, or change their position, or create some type of transformation. So that's very useful, and that vertex shader, it only works or tries to work on this specific matter. And after the vertex shader finishes, it sends a result to the fragment shader. And the fragment shader describes what happens between these triangles. So you can set a color between these three points that describe this triangle. You can set gradients. You can create a huge variety of effects, which is what my library works for. And you will have your compute shaders, which is, I would say, fairly new for web 3D, for 3D on the web. It exists already in other 3D languages, but compute shaders basically help you with math calculations. You can do matrix operations, calculate large arrays. You can pre-process a texture or fill a texture and send it back to the fragment shader. You can do a lot of stuff there that not necessarily means that it's going to be output into a to the screen. You can output that and have other uses. You could have like huge array of data that you could use for other stuff, like it currently exists for machine learning. So now I want to compare my library points with WebGPU alone. For this, I'm going to show WebGPU samples, which I think these are the official WebGPU examples. So you can take a look at them, click on each of these examples over here, and have a look at the amount of code and the shaders. and what they do. So it's a very nice reference to create a program in WebGPU from scratch. But as you will notice, each of these programs, which I consider should be really small, they have a huge amount of setup code. So you wanna do something, you will need to set up a huge amount of code in WebGPU. Then you will have to declare your shaders. Check this for the image blur. So here's the result, and you have to do all this just to grab an image and then apply your blur compute shader into that image, and then to print that into the fragment shader over here. This is a great reference, but I wanted to show you this so you can compare that with my library. And if you take a look, this is basically what you need to declare a basic program. So here you will add your vertex, your fragment, your compute shaders, and that's basically it. That's the comparison that I wanted to make with WebGPU and my library. But of course, my library uses WebGPU underneath. But to use my library and to use WebGPU, you have to understand it. By using my library does not exempt you from learning WebGPU. So here is where I want to explain a bit more about how WebGPU works. So on the left side, you will have your CPU, and on the right side your GPU. So here is imagination time. You will have to use your imagination for this. The CPU is over here and the GPU is over here. In the middle there is WebGPU, and on the left side you will have your JavaScript, you have your C# code, you will have your Python, C++, etc. And on the GPU you will have your Wixel code. So the point that I wanted to make is that for each of these architectures, you'll have a different type of language. It will work different. So if you're wondering why I can't write my my GPU programs with JavaScript or C# or Python, it's because they have a different architecture, and therefore the instructions work differently. So your JavaScript code, Python code, it works sequentially. You have a set of instructions, so it runs one by one. You probably already know that. But the thing with Wixel code or any GPU language is that they run a bunch of minimal instructions at the same time, and very parallelized amount of tasks at the same time. So even in the CPU, when you have your I don't know, 8 cores and you can run 8 threads at the same time, it's not compared to the huge amount of parallel processing that the GPU is making. I think I read this a while ago, that the CPU is smart slow because they can run a bunch of instructions, very different instructions or complex instructions, while the GPU is dumb fast because they can run their limited set of instructions very fast, very parallelized. So now let's talk about communication between both sides. So on the CPU you will have your JavaScript application. I mean your main program in which that you are going to create for WebGPU. So let's try just to show here, like WebGPU is over here, right? Because WebGPU is in the middle. So so your application talks to WebGPU. WebGPU talks to the GPU and it runs your Wixel program. Your GPU says some stuff back to WebGPU, and the GPU and WebGPU talks back to the CPU, to the JavaScript application, and the end result could be two things. You will write something to the screen. Most of the time, that's what you are going to do. You want to print something to the screen, animation, a cube, anything, and sometimes you just want the result, which will be a compute shader. So that's mostly how it goes from the CPU, JavaScript, WebGPU, Wixel, and back, and that's how it goes. The next thing that I want to talk about is variables. So as I mentioned, there are different architectures, but in both sides you have your variable over here, your variable over here on JavaScript. Your arc a1 equals 1, and over here you have your let a1 equals 1. Just an example. Let's rename it to 2, and let's add 2. So you want to send this value to here. That kind of represents a problem, because you have to communicate through WebGPU to send this value over here. And the thing is, the GPU only has a certain amount of slots where you can send variables, meaning like you cannot tell the GPU that you wanted to use this variable, but you need to tell the GPU in which of these predefined slots you are going to attach your variable and therefore your value. So when you get to Wixel, you can check for that specified slot and retrieve that value and use it. In WebGPU, I don't want to get too technical with this, but there's this stuff called bindings, groups and bindings. But let's just think like bindings. So in your binding 0, you're going to assign a1. So over here on Wixel, you are going to check for the binding 1, binding 0. Sorry. This you put your identifier, which it doesn't exactly have to match with a1, but you can add anything like bar a1, I don't know, something like this, and then you can use this value over here. You say a1. This is an oversimplification, but that's more or less what happens. And I think this is the most complex part of WebGPU, that you have to create your bindings for each value that you want to send into the GPU. It doesn't matter what it is. You have to send a texture, a video. You have to send a huge amount of data, a small amount of data. You have to send. You have to create these bindings in a thing that is called the layout. But with my library, you don't have to explicitly say that. You can just assign the value directly, and you can use it without thinking about this. The next thing I want to talk about, it's data types. So let's say in JavaScript, you just declare, I don't know, you have also let here, but by the way, the let in Wixel works different than a let in JavaScript. It works more like a constant, and in Wixel you also have a bar, which works more like a variable, that value that you can change. A let, you cannot change it. There's also constants, but that's a bit different. So in JavaScript you have, I don't know, your numbers. You have something like this. You have your strings, and by the way, regarding the numbers, you also have like your float numbers. You have you can do this, and you can do also endless, and you assign 3.1, and that works, because the number, it doesn't take into account what, if it's a float or not. The value will be interpreted, but in Quixel you cannot do that. You need to define the data type. So if you are going to use a floating number, you have to use F32 type. If you are going to use an integer, you can use I32, which is it has negative values, and then you can use your U32, which it doesn't have negative values, which is unsigned. And you can also have vector values, vec2, vec3, and vec4, which you can set of, for example, F32 or I32 or U32, and they work. And also you can have arrays that you also can set of a type. You can also, if I'm not wrong, you can do something like this, but you also have to set the amount of items. It depends. Depending how you load it into memory, you have to define the amount of items you're going to allocate, or if you are using something that I will explain later, it's called the storage. You can just set it at the end of a struct, and it will assume that the rest of the size that the rest of the value that you're sending, it's all part of that array. There is something else in WebGPU that I wouldn't exactly call it like a data type, but it's more like a behavior between the values. So if you have if you declare a value here and you want to send this value to the GPU over here, you can make this my value be read only. So this value needs to be declared like what it's called a uniform. So this value can be set on the CPU, and it can be read on the GPU. So set here, and you can read the value over here. So if you try to assign something to this, it will throw an error. So this is a behavior from that is unified from the CPU and the GPU. And you can also update this value from the CPU, but you cannot do it therefore in the GPU. But I think I read recently that you can also make these values read-write, but I've only been using them as read-only. If you want to use something bigger, you can use what I'm going to explain next, that it's called storage. So you wanna, again, send the value, but you want to send more values. You want to send a huge array with a lot of values over here. So you can do that with the storage. So you can use my values over here. You can access them with an index, depending of how large you make this array. You can set your array or your buffer, your storage buffer over here, and you can read and write to this buffer, to this variable. So you can set here 10.1. But instead of sending how much values you have here, you just tell them the amount. It's hard to describe here, but you just say I want to send 30 slots or 1024, and you can access them here. You're not setting the values per se, but you're setting how much of this space will be used, and you can use it here. So you can set here. You can also add data here. You can this is a different type of storage. It's called a storage map or mapped. You need to map the data before sending it, and since this is already because when you set this value, I don't know, just here, it's 2 values of 10, so on this side it already knows how many values it has, so you don't have to like explicitly set, because it already knows by its length. There's another thing you can do. Well, if you can write over here, you can also read the values, but these values need to be associated with another variable. But with my library, you can use the same identifier because these values here need to be like copied to another buffer, and that buffer or variable is the one that is going to be read on the CPU side. It's a bit confusing, I understand that, but I hope that with my library it simplifies this a bit. I think that's the most important things about WebGPU regarding to how it works. But the example or the demo that I'm going to make is going to be with my library. So if you wanted to use my library, you have to like check this couple of questions. So again, what is points? Points is my library that has WebGPU on the inside, and it will help you to create mostly 2D effects, post-processing effects, animation, SDF, nothing too fancy in 3D because it's just 2 triangles on the screen that will help you display this data. So is it for you? Do you want to create a framework? I would say then no, do not use my library. You can learn WebGPU from scratch, and you can create your own library. And by doing that, which I recommend, you should do your own library or framework. You can learn a lot about 3D in general, about math in general. I will totally recommend creating your own library. That doesn't mean that people is going to use it. That's not the point. The point is to learn, but I totally recommend it. So you want to create a framework, you want to create a library, then no, don't use my library unless you wanted to build something on top, like mini game engine. Even with that, I will say that you have enough resources with my library to create a small game with it. Do you want to create? You just want to write a couple of shaders? Yes, use my library. As you can see in the example, you only need this, and you can start writing your shaders. Do you want to create a simple application? Well, what do I mean with this? You wanted to create a calculation. You want to use compute shaders. You want to multiply a couple of matrices and get the result back. You want to implement this connecting to your current application. Yeah, why not? It's just simple numbers, and the library will help you to just connect the input output, and it will be super easy. So you want to do something in 3D? I would say no, unless you're I think it's called ray marching, because you can do 3D stuff in the fragment shader, which is with sine distant functions, and it's super cool, but we are not using here a 3D mesh. We only have 2 triangles on the screen, so my library doesn't support loading 3D models yet. I plan to do that in the future, but I don't think I'm going to do it soon. So if you want to use WebGPU in 3D, I will recommend, I don't know, Babylon, 3GS, Play Canvas, which are very mature 3D engines that will help you with that, and my library doesn't do that. So my library is mostly focused on effects, on creating pretty colors, distortions. You can also load sound. You can do a bunch of stuff, calculations, math, that probably you wouldn't be able with 3ds, or would probably have to do a weird combo there. So just use my library for something really quick, and you don't need to like load 3ds for this, or set up a 3D environment for this. Just a very small environment. So okay, so I'm finished here. What I wanted to do now is to create an example of a 3D application. So I'm going to put this thing back. Sorry if you can't see, I will try to zoom in, but if you get the repository, there is this basic HTML. So there's this basic HTML into the examples directory. The index is the one that you will see here, that it has all these demos running. They will work, and they will help you to create your applications if you want to create one. But this is very bound to a huge amount of code on this main file that probably you don't want to use. So you can just load the basic HTML, but I'm going to make a small modification here just to being able to use the code hinting here. I'm going to add a basic.js. So I'm going to move all this code, all this JavaScript code over here. Here. So now we have the hinting. Let me just format this. This part didn't move. Let me just go move this a bit, just so that it's easier for everybody. And I am going to basic.js, and let's check if it's working. Here is the examples basic. Let's see if I imported this wrong. Okay, it's working. So it will be very easy to me to say this is your first application and that's it. But let's see, you have this is the main library, this points, this is the render pass. You need to let's put it this way. You can layer up your effects, your projects. I mean, you have here this effect. You can add another one on top. So that's what the render passes do. But let's not think about it. Let's just modify this a bit. Here you have your compute shader. You don't actually have to add your compute shader. You can remove it. Let me see here. You can remove it. It should work if you remove your compute shader, because it's doing nothing. So yeah, you need your vertex and fragment shaders. Those are required. And let's say that you just let's remove here this. You just want to send a back for return to the screen, because this is your fragment shader. We have two triangles on the screen. You want to print red color, and let's see if it works. Sometimes it requires you explicitly say that it's a floating point, but okay, this works. You can send a red color over here. So let's say that from the JavaScript side, you want to send a value over here. So let's add a name. So you want to send the red color over here. It's red color, and you want to say that this is 0.5 for the red color. You want to send green color. You want to send 0.1, and you want to send your blue color. You want to say it's 0.5, and you don't want to send an alpha, or it's not required here. Well, from the library, the uniforms that you send over here are all allocated into a structure called params. So you can call it, you can retrieve this value by doing this red color. So let's just grab this value and paste it here. So that gives us the 0.5 red color. So it will look half the red value we have. So that is correct. So I wanna here params dot green color and params dot blue color, and we don't touch the alpha. We will have whatever color we get from combining these three values, which is violet, purple color, which is quite nice. So as you can see, you don't need to set up like this huge amount of code about setting up the layout, which this is the library over here. You can see the huge amount of code that it requires just to create this setup. At some point you have your layout. You have to create all this manually. You don't have to with my library. You only have to send a bunch of values and use it. You can also, let's say, you can add a texture image. Let's see, I know I have a few images over here. I think they're in examples. No, I'm wrong. This is here image, so I can invoke, I don't know, it's called the Gioconda, but this you have to add the name to it. So let me check which are the parameters. Oh, and these have to be a weight, because this resource returns a promise, so you have to await this. There are other methods that do not require an await, but these resources require that, so you have to send a name, a path. There's also shader type, but that's not required. You can send let's say Gioconda image here. So this name that you set here is the one that you can invoke on the on your fragment shader. So I also have a bunch of functions to work with certain values. I know that you can use like texture sample from WebGPU, Wixel to parse and sample your image, but I have to make my own to sample the image because the image, when you read your image, you will notice that it's reversed. So I have to create my own. So there is this texture position, and this is going to I think, yeah, you have to you have this texture position is in its own module as a string. It's a piece of Wixel code that you import via JavaScript. You don't have to do it this way. This is the way I do it. So you have your method over here, and then you have to import your explicitly concatenate the method here. So this texture position is a custom method, so you will have to send your well, it will return the current color in the UV position. So the name of the image is Gioconda image, so I will pass that here, and then I think it's the position, second parameter. No, you need a sampler. Yes, a sampler will help you to parse your image. Point at sampler. So you got a name to my image sampler, and you can set a descriptor, which I'm not going to use here, but it will help you to create a more pixelated image or a more softened image. But you can investigate that. So you pass your sampler here, and let me check the parameters. You send your position. Your position will be 0 0, so back to empty, and you will send the current UV that you have, which my library already sets two types of UV for you. So you have your regular UV, but the UVR will fix any distortion if your window over here, it's a 1:1 ratio. If it's bigger, this is wider, it will compensate the scale. So you will want to use UVR. So UVR is the UV times the ratio, if you want to know where that comes from. And last value is a true, which means it's going to crop the image because there is like some bleeding from the image. You want to probably cut that. So that's how you do it. And this will return, let's call it color, and this will get the current value of the image. And well, let's just comment out this, and you will pass your color over here, which will be, hopefully nothing fails, the image. So let's see what I did wrong. I redeclared color. Oh, I see what I did. This color is declared here. This color over here is the one that comes from the vertex shader. So your vertices sometimes have a color. This is how you can retrieve it, but we're not going to use that. So let's just use, I don't know, image color, and replace that with this. So yeah, that prints our Gioconda image without a trouble. If you want to know what the color has, I think I already set a few colors in case you want to you want to try it. So it has a rainbow color, so that's what it has. But if you have your own 3D model with baked colors in the vertices, that's kind of what you will see. So that's how you retrieve the color from a texture image. You have to sample it. You can also have a mouse position. You can do stuff with this. I mean, you can put your mouse here like in start position, I think, because it's a vec2. So your image will be where your mouse is. So super simple. You can use this for a game. You can do a lot of things with my library, like creating events, firing events. You will send a message from the Wixel code to the JavaScript side. You can fire a sound. I don't know. You can do a lot of things with it. Let me show you here what we get on the index. But you can do your shaders. You can you can run audio if you like. This, let me just enable the so this generates audio, and when I click on the screen is when the audio plays. So that's how it works. I have a bunch of stuff that will help you. My library has a bloom. I have a bunch of methods that you don't have to recreate. This is data demo. It executes a compute shader and returns a result to the console. It doesn't print anything. This is what I just showed you. This is just like the most basic demo. You have a dithering example over here. You can manipulate the values and see what it returns. This is the event example. So from the Wixel code, I fire some events, and you can read those events on JavaScript. So very useful. These are 3 stacked images which you can put on top of one another. Simple image texture example. This texture with you are manipulating the colors. This distortion with the UV mapping. This is the image with a bleeding. These layers, it's there but it's not visible. It's just an example. You have to check the code for that. This mesh example, it shows how you can manipulate the 3D mesh even when you are not exactly we are not exactly loading a huge 3D model, but you can change the density if you wanna do something with it. You have mouse position, which I already showed you how to do that. You have other events like this is the scroll. You can click, so that's useful too. How to create noise and how to manipulate these values, which are very cool. There is a lot of examples here. Render passes to create cool effects. Change the render passes too. This is a more complex one. This has like 9, more like 10 render passes, and on the console. That's something I forgot to mention. Each time you run your render pass or your program, you can see a print of the program, that current program, your fragment, your vertex shader, so you can debug what you are doing. So if I go back to the basic example, here you have your render pass, so you can see your vertex shader over here, and you can see your fragment shader, which it has a lot of stuff like you're currently not using, like this sound and event, but they are available for you to use. So yeah, that pretty much is my basic overview explanation, not only on WebGPU but with my library. I hope you like it. If you have any questions, just let me know. Improvements. I mostly created this library for me. If someone uses it, I would love to know if it's useful or not. But yeah, that's pretty much it. Thanks for watching.